Hello everyone. Now we are going to study the next algorithm on the big data optimization, that is your estimation of distribution algorithm, or simply it is called the EDA. Then what is the use of the EDA, that is estimation of distribution algorithm? Already you know that genetic algorithm. So now go to the basic concept. Now already know the genetic algorithm. It has the initial population, evaluation, selection, crossover, mutation. So it is a continuous process until you get the final solution, optimized solution. But another one is your EDA algorithm, estimation of distribution algorithm. Here what is doing? You are using the probability. You are not using crossover or mutation. You have the steps. Initial population is there, evaluation, selection. Then in case of crossover mutation, you are using probabilistic model building, that is using either the Bayes theorem, that is the conditional probability, or you can use some simple other types of probability to get the best sampling child population. So based on the probability you are getting the sampling child. But here in the crossover you have to go for the different types of operations. Again go for the mutation. A mutation sometimes fails, crossover also sometimes fails, and you not get any best child or best population. So here you are using the probabilistic model. Now what is the negative effect? Now to overcome the negative effect of the crossover and mutation, approach of variation, a probabilistic approach of variation has been proposed. The algorithm using such approach is known as EDA or PMBGA. PMBGA means probabilistic model building genetic algorithm. The alternate name of the EDA is PMBGA or probabilistic model building genetic algorithm. Now what we will study in this session, we will familiarize with the estimation of distribution algorithm and applications. The objective is to demonstrate the estimation of distribution algorithm, describe the applications of estimation of distribution algorithm, list out the properties of the EDA, solving the optimization problems using EDA. Your outcomes is that define what is EDA, describe the properties and application of EDA, and summarize the concept of the EDA applications. Now EDA is one of the powerful evolutionary algorithm for solving continuous and combinatorial optimization problems. And continuous combinatorial problem generally solved by the EDA, but is not solved by the genetic algorithm easily. Based on the machine learning techniques, for each generation, EDA's estimate a joint probability distribution associated with the set of most promising individuals, trying to explicitly express the interrelations between the different variables of the problem. Based on this general framework, EDAs have proved to be very competitive for solving combinatorial and continuous optimization problems. So EDA are optimized methods that combine the idea from the evolutionary computation, machine learning, and statistics. So it is a combination of three operations, that evolutionary computation, that is already studied, the PSO, genetic algorithm, machine learning techniques to optimize the values, then statistics to using the joint probability or any probabilistic calculations. Estimation distribution algorithms are stochastic optimization algorithms that explore the space of candidate solution by sampling an explicit probabilistic model constructed from promising solutions found so far. EDAs typically work with a population of candidate solutions to the problem, starting with the population generated according to the uniform distribution over all admissible solutions. So, I am using here the uniform distribution for the particles or the candidate solutions. The population is then scored using the fitness function. The fitness function gives a numerical ranking for each string. With the higher the number, the better the string. From this ranked population, a subset of the most promising solutions are selected by the selection operator. Already in the genetic algorithm there is a selection operator and rank population algorithm also there. In example, an example selection operator is truncation selection with threshold to t is equal to 50%. We select the 50% best solutions. So we taken the 10 initial solutions, then out of 10, 50% will be selected as the best solution. The algorithm then construct a probabilistic model which attempt to estimate the probability distribution of the selected solutions. Once the model is constructed, new solutions are generated by sampling the distribution encoded by this model. The new solutions are then incorporated back into the old population, possibly replacing its entirely. The process is repeated until some termination conditions or criteria is met. Already we know what are the terminal criteria, that is the error calculation or the number of iterations. With each iteration of this produce usually referred to as one generation of the EDA. Like genetic algorithm, each solution is one generation. So this is the flow chart of the EDA, and initialization of the variable and generation of the initial population. Termination criteria satisfied, yes, then simulation ends, otherwise no. Fitness calculation, updating the best solution, best iteration, number of best fitness value, best iteration number and best fitness value. Next, selection of NB best solution, that is the next generation best solution. Estimation of probability distribution, so again go for the probability distribution. Thresholding enabled, yes, apply the thresholding and generate a new population. Again it will go to the verify the criteria, termination criteria. If the thresholding is not enabled, then generate a new population. Again you start from the termination criteria. So the process will continue until your termination criteria satisfied, that is the number of iterations or the level of the errors. Functions in the algorithm. Selection function function goal is to choose the most interesting solutions. For instance, truncation selection chooses a percentage of the best solution from current population. The essential steps of EDA are the estimation and simulation of the source distribution, which is implemented by the learn and sample functions. The learning estimates the structure and parameters of the probabilistic model, and the sampling is used to generate a new solution P prime from the probabilistic model. Finally, the replacement function defines the next population. So this is the algorithm of the EDA. Input F and C. F is the fitness function, C is the control parameters, P is the initialization, C initial population, all the C values. If required, then P is the local optimizer, PFC. Apply local optimizer to P and F. B is the best PF, best solution, I0. While not termination criteria PFC, do P prime is the selection PFC, M is the learn P prime is the sample of M, that is the P prime selection of PFC, that is selected population P prime. M is the learn P prime, set probabilistic model M using a learning model method. So you apply some model, probabilistic model, to get the new population. P prime is the sample M. Set sampled population from M using a sampling method. If required, then P prime is local optimization P prime FC. Apply local optimizer to P prime and F. B the best, B best of the B, P prime and F. P is the replacement of P, P prime, F and C. That is what is the new generation you got, that will be replaced with the original population, and what is the already there, that will be removed. That is what you selected in the previously. Then go for the iteration. Continue till the termination criteria satisfies. And final output is the B, that is the best solution. So this is the scheme of the EDA. Generate the set solution, evaluate, then you get some different colors, elements of particles are here or objects are here. Then select, which one select, you get the select best one. So best one will be selected. Estimate the parameters of the probability distribution. Now sample new solution, so apply the some parameter for the probability. Again you get the new solutions from the existing one, then evaluate and you get final solution. So the process will be continue, and what are the selected here, that will not continue in the new old population. New data will be added in the old population. Next, after the evaluation, update the set of solutions. So this data will be added here and all data will be removed. So its right side you see the blocks, that will be removed. Types of EDA, there are various types of EDAs are available: univariate, bivariate, multivariate. Then advantages: global optimization, model based approach, adaptive search, parameter tuning, versatility, robustness, parallelism. At disadvantage: computational complexity, convergence issue, model estimation errors, limited applicability, high memory requirement, because every time you are using the so many childs from the population or parents from the population, high memory requirement, lack of domain specific knowledge, so there is no specific domain is available, sensitivity to parameter settings. Now one example is solving one max with a simple EDA. So you have the one max problem is that you have to maximize one of the function summation of xi. So your binary inputs are x1 to xn. The quality of a candidate solution improves the number of ones in the input string, and optimum is string of all ones. In this example, our population size is set to n equal to 6 with n equal to 5, small n equal to 5 binary variables for solution. So every population has 5 binary values. Truncation selection is tau is equal to 50%, and subset of the most promising solutions are based on the 50% best solutions. Estimate the probability of distribution of these promising solutions. A probability vector is used that store the probability of a 1 in each position of the solution strings. So this is the example. You selected 6 bits or 6 strings. Truncation error is 50%. So 50% you will take. What is the highest value? The 3 ones, 4 ones, here 0, 1, 1, here 4, 1, here 1, 1, here 2 ones. So you take the 50%. The 50% means out of 6, 3 are eligible. So 4, 4, 3 are eligible. So now what is the probability vector? So every case what is the probability? The 3 ones are there, 3 by 3, 2, 2 by 3, 1, 1 by 3, 3, 3 by 3. Now sample. What is the sample now? 4, 3, 4, 3, 4, 4. So same data with different positions we are taking, because all are the 4, 3, 3, 4. Next, from this truncation error 50%, again take the best 4, 4, 4. Now again take the probability 3, 3, 3, 3, 3 by 3, 3 by 3, 2 by 3, 1 by 3, 3 by 3, and sample is again all are 4, 4. Again you are getting 1 is 5. And finally you get a solution in the based on the 5. So you have to find the probability vector is important to find a new offspring or new child. This is a probability vector on 1 max. Advantage: global search, adaptation, no need for gradients, versatility, scalability, exploration and exploitation. Disadvantage: computational cost, complexity, parameter tuning, convergence, limited success for certain problems, sensitive to the initialization. Again, there are so many variants and applications are available. So this is the end of the topic EDA, and hope you enjoyed the session.